Hello everyone, this is Kalpana here. In this video, we're going to solve a differential equation using integrating factor x power alpha y power beta or x power h y power k. So let's get going. Problem solve y cube minus 2yx square into dx plus 2xy square minus x cube into dy equal to 0. Given differential equation, y cube minus 2yx square into dx plus 2xy square minus x cube into dy equal to 0. Consider it as equation 1, which is of mdx plus ndy equal to 0 form, right? Where m is y cube minus 2yx square and n is 2xy square minus x cube. We can say that 1 is exact if partial derivative of m with respect to y equal to partial derivative of n with respect to x. So let's now find partial derivative of partial derivative of m with respect to y and partial derivative of n with respect to x. Dou by dou y of m, y cube minus 2y x square. We can write this as dou by dou y of y cube minus dou by dou y of 2xy square. Since it is a partial derivative with respect to y, so we'll treat x as constant. So in the second term, 2x square is constant. So we can write this as 2x square into dou by dou y of y, right, which gives us partial derivative of y cube with respect to y is 3y square minus 2x square into partial derivative of y with respect to y is 1, which is 3y square minus 2x square, right? Let's find the partial derivative of n with respect to x. Dou by dou x of 2xy square minus dou by dou x of x cube. Since it is a partial derivative with respect to x, so we need to treat y as constant. So here 2y square is constant. You'll get 2y square into partial derivative of x with respect to x minus partial derivative of x cube with respect to x, which gives us 2y square into partial derivative of x with respect to x is 1 minus partial derivative of x cube with respect to x is 3x square, which is 2y square minus 3x square. Therefore, dou n by dou x equal to 2y square minus 3x square, right? So this shows that partial derivative of m with respect to y is not equal to partial derivative of n with respect to x. See, we are having 3y square and in this we are having 2y square. Here you have 2x square and here you are having 3x square, that is minus 3x square and minus 2x square. Therefore, partial derivative of m with respect to y is not equal to partial derivative of n with respect to x. This shows that 1 is not exact, right? We have 1 y cube minus 2yx square into dx plus 2xy square minus x cube into dy equal to 0. You can write this as y cube dx minus 2yx square dx plus 2x y square dy minus x cube dy equal to 0, right? So in the first term you're having y cube dx, so, and in the third term you're having y square, right? From these two terms we can take y square common, okay? And here you're having x cube dy and here you're having x square. You can see we don't have any x square in first term and third term, so you can take x square common from these two terms, okay? Let's write these two terms, that is involving y cube and y square together, and these two terms last we'll get. Firstly we'll write the terms involving y cube and y square. We'll get y cube dx plus 2x y square dy. Now write the terms involving x cube and x square. I'll write second term firstly and the last term. Now we can take y square common from the first two terms. We'll get y square times y dx plus 2x dy plus take x square common from the next two terms. We'll get x square times minus 2y dx minus x dy equal to 0, right? Also here you're having y square, right? And you don't have any x term here, so we can write this as 1 into y square. Since we don't have any x term, so we can write 1 as x power 0, right? So you can write this y square as x power 0 into y square into terms under brackets remains the same plus here you're having x square, there is no y term, and we can write x square as x square into 1, replace 1 as y power 0, you'll get x square y power 0, since y power 0 is 1, right? So you can replace x square by x power 0 into y power 0, x square y power 0 into terms under brackets remains the same. Consider as equation number 2, which is of the form x power a y power b into my dx plus nx dy plus x power c y power d into py dx plus qxdy equal to 0, where a, b, c, d, m, n, p, q are constants. By comparing these two equations, we'll get the values of constants, okay? Where a0, b equal to 2, c equal to 2, d equal to 0, m equal to 1, n equal to 2, p equal to minus 2, q equal to minus 1. Since the given differential equation can be written in this form, so here the integrating factor is x power alpha y power beta. Now we need to find alpha and beta using some formulae. So we are going to use a plus alpha plus 1 by m equal to b plus beta plus 1 by n and c plus alpha plus 1 by p equal to d plus beta plus 1 by q to find alpha and beta. So now I'll go with first formula. Substitute the values. A 0 plus alpha plus 1 by m 1 equal to b 2 plus beta plus 1 by n 2. This gives us alpha plus 1 by 1 equal to beta 2 plus 1 3 by 2, right, which gives us 2 times alpha plus 1 equal to beta plus 3, right. From this we'll get 2 alpha plus 2 equal to beta plus 3, which gives us, just bring this beta to LHS, take this 2 to RHS, you'll get 2 alpha minus beta equal to 3 minus 2, which gives us 2 alpha minus beta equal to 3 minus 2, 1. Consider it as equation number A. Now consider the second formula. C plus alpha plus 1 by P equal to D plus beta plus 1 by Q, which gives us C, substitute the value C 2 plus alpha plus 1 by P minus 2 equal to D 0 plus beta plus 1 by Q minus 1, which gives us alpha 2 plus 1 3 by minus 2 equal to beta plus 1 by minus 1, right. We can write this as minus 1 into alpha plus 3 equal to minus 2 into, just make cross multiplication, minus 2 into beta plus 1, right, which gives us alpha plus 3 equal to 2 beta plus 2, right. Now bring this 2 beta to LHS and take this 3 to RHS, you'll get alpha minus 2 beta equal to 2 minus 3, which gives us alpha minus 2 beta equal to minus 1. Consider it as equation B. Now solving A and B, we'll get alpha and beta values. We have 2 alpha minus beta equal to 1, equation A, and alpha minus 2 beta equal to minus 1, equation B. In order to solve the two equations, we need either a 2 in beta or a 2 in alpha, I mean in first term of second equation, right. In order to cancel alpha, we need 2 here, right. So we'll multiply 2 to this equation B, so that we can cancel terms involving alpha while solving equation A and B. So let's multiply this equation B by 2. Solving A and B. So now multiply equation B by 2, you'll get 2 alpha minus 2 2s are 4, 4 beta equal to minus 1 into 2 minus 2. Change the signs. Plus 2 alpha minus 2 alpha gets cancelled. Minus beta plus 4 beta is plus 3 beta equal to plus 2 plus 1 is 3. This gives us beta equal to 3 by 3, which is 1. Therefore, beta equal to 1. Now consider equation A. We have equation A, which is 2 alpha minus beta equal to 1. Since we got the value of beta, so we can substitute beta by 1 or you can take this beta to RHS and then substitute beta value. Beta is 1, this is 2. From this we got 2 alpha equal to 2, which gives us alpha equal to 2 by 2, 1. Therefore, alpha equal to 1. So we got the values of alpha and beta. Alpha is 1, beta is 1. Therefore, alpha equal to 1, beta equal to 1, right? Then the integrating factor will be becomes x power alpha y power beta equal to x power 1 into y power 1, which is xy, right? Therefore, xy is the integrating factor. Now, multiplying 1 by integrating factor, xy will get xy into y cube minus, see, after multiplying the given equation by integrating factor, the given equation becomes exact, okay? This gives us xy into y cube, y into y cube, y power 4 minus 2, x into x square, x cube, y into y square into dx plus 2, x into x square, y into y square, y cube minus x into x cube, x power 4 into y into dy equal to 0, right? Consider as equation number 4. Sorry, it's 3, right? Equation number 3, which is in, say, m1 dx plus n1 dy equal to 0 form. Where m1 is xy power 4 minus 2x cube y square, and n1 is 2x square y cube minus x power 4 y. Let's check whether the reduced equation is exact or not. So that we'll find partial derivative of m1 with respect to y and partial derivative of n1 with respect to x. If partial derivative of m1 with respect to y equal to partial derivative of n1 with respect to x, then we can say that the reduced equation is exact, and later we'll find the solution, the general solution of this exact equation, okay, if it's exact. Let's see. Firstly, we need to check whether it is exact or not. Since it is partial derivative with respect to y, so here x is treated as constant. You can write this as x into partial derivative of y power 4 with respect to y minus 2x cube into partial derivative of y square with respect to y. This is equals to x into partial derivative of y power 4 with respect to y is 4 y cube minus 2x cube into partial derivative of y square with respect to y is 2y, which gives us 4x y cube minus 2 to the 4 x cube y. Therefore, partial derivative of m1 with respect to y is 4xy cube minus 4x cube y. Let's now find partial derivative of n1 with respect to x. Dou by dou x of n1, 2x square y cube minus x power 4y is equals to dou by dou x of 2x square y cube minus dou by dou x of x power 4y. Since it is partial derivative with respect to x, so here we are finding partial derivative of some term with respect to x. So y is treated as constant. Here 2y cube is constant and in the second term y is constant. So we can write this as 2y cube into dou by dou x of x square minus y into dou by dou x of x power 4. Right? Which gives us 2y cube into partial derivative of x square with respect to x is 2x minus y into partial derivative of x power 4 with respect to x is 4x cube, which gives us 2 to the 4 x y cube minus 4 x cube y. Therefore, partial derivative of n1 with respect to x is 4x y cube minus 4x cube y. See, we have the same thing. So from this we can say that partial derivative of m1 with respect to y equal to partial derivative of n1 with respect to x, and the reduced equation is exact. Therefore, partial derivative of m1 with respect to y equal to partial derivative of n1 with respect to x equal to 4xy cube minus 4x cube y. Therefore, the reduced equation, equation 3, is exact. And the general solution is given by integral m1 dx treating y as constant plus integral n1 terms of n1 free from x into dy equal to c. Now let's find the two integrals separately. Integral m1 dx treating y as constant equal to integral m1 xy power 4 minus 2x cube y square into dx is equals to integral xy power 4 dx minus integral 2x cube y square dx. So here we are saying that y is treated as constant, so y power 4 is constant in the first term and 2y square is constant in the second integral. In the second integral. Let's take the constants outside the integral. You get y power 4 integral x dx minus 2y square integral x cube dx. This gives us y power 4 into integral x dx is x square by 2 minus 2y square into integral x cube dx is x power 4 by 4, which gives us x square y power 4 by 2 minus x power 4 y square by 2, or x square y power 4 minus x power 4 y square by 2. Therefore, integral m1 dx equal to x square y power 4 minus x power 4 y square by 2. Integral n1, terms of n1 free from x. Into dx equals to integral. Just observe n1. You're having n1 equal to 2x square y cube minus x power 4y. We don't have terms which are free from x, right? So here we are asked to write terms of n1 free from x, but we don't have any terms which are free from x, so it is 0. Integral n1 terms free from x into into dy is 0. Okay, now coming to the general solution. Therefore, the general solution is given by integral m1 dx treating y as constant plus integral n1, that is terms of n1 free from x into dy equal to c. The result obtained from the first two integrals is, the result obtained from the first integral is x square y power 4 minus x power 4 y square by 2 plus the result obtained from the second integral is 0 equal to c, which gives us x square y power 4 minus x power 4 y square by 2 equal to c, right? Or x square y power 4 minus x power 4 y square equal to 2c. Or we can write, since c is arbitrary constant, 2 is constant, so you can write 2c as some capital C. Then we'll get x square y power 4 minus x power 4 y square equal to c. Or just take x square y square common from these two terms, we'll get x square y square of y square minus x square equal to c, which completes the problem. Therefore, x square y power 4 minus x power 4 y square equal to c, or x square y square of y square minus x square equal to c is the required solution. So we have seen a problem from differential equation in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.